Welcome back, friends, for the course on micro irrigation, and this time the lecture on crop specific irrigation and fertigation scheduling, including decision support system. I am TVS Rajput, and I think we know each other. I'm PhD in soil and water conservation engineering. I have 40 years plus experience of research in water management, and I have served as faculty at Postgraduate School of Indian Agriculture Research Institute, New Delhi. And I have published 10 books and over 200 articles. I have received many awards, including Best Teacher Award and the Best Researcher, the Rafi Ahmed Kidwai Award from Indian Council of Agriculture Research. Presently, I am adjunct professor at Indian Agriculture Research Institute, and Professor Jaishankar, Telangana State Agriculture University, Hyderabad, and also I am visiting professor at Asian Institute of Technology, Bangkok. We are going to speak on fertigation, and that to crop specific irrigation and fertigation. Irrigation we all understand, and fertigation is the combination of two things: fertilizers plus irrigation, that is fertigation. Means application of fertilizers along with irrigation water to the crops is termed as fertigation. Now, fertigation is very advantageous. Let us see to the advantages of fertigation. Number one, it improves yields and quality, and which is very important, because if you can improve the quality of produce, you can get more income, more profits. And if the yield gets increased, your profitability is further enhanced. And this is reduced time function in nutrient concentration in soil in the course of growing season. Better distribution and higher uniformity of plant nutrients throughout the entire root zone on soil profile. Now, this is very important. Normally the fertilizer, how they are applied, manually. A person takes them in hand and throws into the field and keeps throwing. And the distribution is very non-uniform. But when it comes to micro irrigation, the fertilizers are dissolved in water, or they are liquid fertilizers, and then along with water they flow. So wherever the water goes, the fertilizer goes. And drip irrigation, we all know the water use efficiency is the highest, because the water is made to reach each plant at a very slow rate and in the quantities that is required by the plant. So if that is the case, then fertilizer also gets distributed only to the plant root zone, and in the process you save a lot of fertilizers, that is a lot of money. Better and immediate penetration into the soil. Now if you take any granular fertilizer and throw it onto the surface, it takes a while till it gets into the soil and then is made available to the plant roots. But if you apply it through fertigation, it moves along with water, it is available to the plant roots immediately. Then it is easy adaptation of the amounts and concentration of specific nutrients to crop requirements, stages, and climatic conditions. Now, what it says that if we know what is the requirement and when it is possible through fertigation, and it is through fertigation to match the actual requirement in terms of time and in terms of quantity. And you can also have the application, number of applications in frequently in small doses to increase availability, but also reduces nutrient losses from soil surface and leaching. When we apply fertilizers through conventional means on surface, then quite a lot of nutrients, they get wasted through evaporation and other chemical processes. And when it gets to the soil, and then if we do the surface irrigation, then lots of water gets leached down, and along with the water, these nutrients that you are applying through fertilizer, they also get leached down, which is not a case in fertigation, because in fertigation we apply controlled quantity of water and controlled quantity of nutrients, and careful regulation and monitoring the supply of nutrients is possible, and fertigation adapts to automation easily, increasing accuracy, because the entire flow is under controlled and closed conduits. Its regulation, control, and automation is simple, and that's how the irrigation and fertigation can be automated through micro irrigation systems. Now we were talking of the use efficiency, fertilizer use efficiency. There are some data available. If we take a case of nitrogen, phosphorus, and potash, these are major nutrients. If we apply through soil surface, the soil application we call, the efficiencies of nitrogen use achievable are 30 to 50%, phosphorus as low as 20%, and potassium around 50%. But if we applied water through drip irrigation and nutrients through surface, the conventional method, then nutrient use efficiency of nitrogen around 65% can be achieved, phosphorus around 30% can be achieved, and potassium up to 60% can be achieved. But when we talk of the plus fertigation, then these efficiencies achievable for nitrogen is 95%, for phosphorus around 45%, and for potassium as high as 80%. So we can see we can save a lot of fertilizers if we apply it through fertigation. Now, a few things are very important, like soil moisture, root zone depth, effective irrigation, and daily water use. In deciding the irrigation schedules, when we have to apply irrigation, then we must have the idea of these four parameters. What is the present soil moisture? What is the root zone depth? And effective irrigation, how much is required? And what is the daily water use? So that we can estimate the actual water requirement quite precisely. And with that, if the irrigation is scheduled properly, fertigations depend on the irrigation schedule, because fertigation cannot be done only for fertilizer alone. It has to be along with irrigation. So fertigation can be done only when the irrigation is done. So irrigation scheduling must be appropriate, and then in between the fertigation can be applied. Now it's important to understand what is the crop water requirement, and crop water requirement can be estimated from number of ways. I am giving you a few steps for estimating evapotranspiration, the water requirement in the simplest most method, and which is evapotranspiration. That is a term combination of evaporation and transpiration. Evaporation is the loss of water from soil and open surface, water surface, and transpiration is the loss of water from the plant body. And the crop water use can be determined by multiplying the reference evapotranspiration by a crop coefficient. There are two new things here. Reference crop evapotranspiration is the loss of water through evaporation and transpiration from a reference crop, or from simplicity for ease, you can understand from a situation where water is not limiting and the crop is very good and having full canopy. And crop coefficient is the parameter that has been introduced to take care of the variations in water requirement at different growth stages of the crop. We'll be seeing it in due course. Now, after we know the ET0, that is reference crop evapotranspiration, multiply it with the crop factor, we get crop evapotranspiration. Okay, evapotranspiration of the crop. So this is understood. Then let us see. A plant grows like this in its growth cycle, but the water requirement is not uniformly increasing, but it takes this shape of the curve that you are seeing, the red curve. 0.1, 0.3, 0.5, 0.8, 0.9 goes up to as high as 1.1 in this particular graph, and then it reduces again. Why it reduces? Because when the plant gets matured, it starts decreasing or losing its canopy, and its water requirement keeps decreasing, and that's how the crop coefficient becomes less. The highest crop coefficient at the time when the plant has the largest canopy, and the canopy is full and it requires more water. So the simple curve that you had seen, this curve, if we see the plants, normally the plant life is divided into 4 growth stages. And during these 4 growth stages that you are seeing, 1, 2, 3, and 4, the graph is non-uniform like this. But for simplicity and for our calculation, we can simulate this curve. And for simulation, we can make use of this fact that crop coefficient during the initial or early phase remains almost constant. And also when is a mid-season crop, when is the mid-season or the mid stage of growth, there also the crop coefficient is expected to remain constant. Now, after initial stage, the crop development stage, it starts from a value of crop coefficient initial value to it goes to highest value of Kc, which is in the mid-season. And after the mid-season is over, then crop coefficient during late season, it keeps on decreasing continuously. So the actual curve which you had seen in the last 2 slides can be simulated like this. And if it is simulated like this, what are the minimum number of points to simulate this curve? One is the point between anywhere in the initial stage, another point anywhere in the mid stage, and the last point at the end. So if we know the values at 3 different points, we can simulate this curve, which is the crop coefficient curve. For the information of all of you, if you look to FAO publication number 58, it is available on Google free of cost. You can have is a huge document of 400 plus pages, and this curve is defined in detail. And then you will find these three values, Kc initial, Kc mid and Kc end, for most of the crops grown around the world. So if anybody wants to estimate the crop water requirement, and if it doesn't have the local data of the crop growth and its water requirement, it is good to refer to FAO 58 document and get these three values, and use these three values. The crop coefficient curve can be simulated as shown here. Now there is another factor called canopy factor, and this is important for particularly the orchard crops or the crops where the plant spacing is too large. And here you can see it is often 0.3 for widely spaced crops, 0.5 for medium spaced crops, and closely grown crops it becomes 1. So now what is the canopy factor? Canopy factor is a ratio between the plant spacing and the actual canopy. So actual canopy area divided by the plant spacing, the ratio is called the crop factor. So one thing can be noted, the smaller the canopy factor, smaller will be the water requirement. For example, if the canopy factor is 0.5, then whatever is the regular estimation of water for the crop, it could be halved because its canopy factor is half. That's what I was telling. The crop water requirement is multiplied by the corresponding crop factor. For example, here in this equation, the crop water requirement of the initial phase is estimated through evapotranspiration of the corresponding, this is the crop evapotranspiration ETC of the initial stage multiplied by crop factor or the initial stage. So that's how the crop water requirement on any particular ith day can be worked out. Now for developing the fertigation protocols, we have to consider several parameters like fertilizer requirements of crops, soil fertility status, fertilizer application correction factors, basal application fraction, and fertilizer availability concentration, and then solubility, compatibility of fertilizers. Now let's take one by one. Fertilizer requirement of crops. How much is the total nutrients requirement of a crop throughout its growing season? This comes by a lot of experimentation, but many experimentations have been done, and these general values are available for different crops and for different areas. Now soil fertility status says that before applying any nutrient to the soil, we must have an idea how much the soil already has. Now what is the status of that particular nutrient in the soil that already exists? Maybe already there is enough of that nutrient in the soil, so we need not apply, or we need to apply a lesser quantity. We will discuss all that. Application correction factor is that if we apply, if the requirement is 100 units, we need to apply a little larger, a little more than that. Why? Because some of it is likely to get evaporated and lost through other means. So taking care of that use efficiency factor, the crop factor is devised, and crop factor is always more than 1. So whatever is the requirement, the actual that's to be applied is always more than what is actually required. Now basal application fraction is that not all the 100% requirement of all different nutrients is to be applied only through fertigation. There are certain nutrients which are better used if they are given through basal application or soil application at the time of sowing or even before that. Now, whatever fertilizers are available, let us say we have to apply certain nitrogen, and some nitrogenous fertilizers are available, maybe 1, 2, 3, 4, 5. All different available fertilizers may contain different concentrations of the nitrogenous fertilizer, nitrogen. So we have to understand that, take care of that. If it is not 100% concentrate, which is normally not the case, if it is 50% concentrate, then if nutrient requirement is 100 units, then fertilizer we must apply the 200 units. Am I clear on that? Now similarly, we'll have to also see that what is the solubility of the fertilizers that we are using. By applying on surface, it doesn't make a difference what is the soluble, how soluble it is in water. But once you are applying it through fertigation along with irrigation water, must ensure its solubility and should be a perfect solution. There should not be any precipitation possibility or any settlement possibility, silting of any particle or anything inside the micro irrigation system. That's why the compatibility is also to be accounted for, that if you are applying two nutrients or two fertilizers simultaneously together, then they must be compatible to each other. Means they should not react among themselves or react with water to make any precipitation. So the compatibility must be ensured before mixing two or before applying two or more fertilizers together. The important thing I was talking about is the basal fraction. If you see, it depends mainly on the method of water application. If you take surface application, it says basal dressing, basal, that means soil application, must be 30% of the total nitrogen and 100% of potash, phosphorus, calcium and magnesium through basal dressing. And 70% remaining nitrogen must be given by top dressing. And if you take the case of drip irrigation, on the other hand, it says that basal dressing of nitrogenous fertilizer should be 30%, phosphorus 60%, potash 40%, calcium 80%, magnesium 80% of the total requirement must be given as base dressing soil application. The remaining fertilizer, 70% of nitrogen, 40% potash, 40% phosphorus, 60% potash, 20% calcium, 20% magnesium, that should be given through fertigation. Now we are applying different fertilizers. Why? Because the plant requires different nutrients. But plant require different nutrients, different concentration at different stages of their growth. If we can really get to that level, then we can make plans or we can schedule our fertigation application as per the requirement of the plants for the best productivity. In this curve, what you are seeing is the generalized nutrient uptake curve, and all different crops will have this curve different for different N, P and K and any other nutrient that you work out. They are all different shapes depending upon the plant type. Now I'll show you a few of the crops. How do they work? Let's say a case of wheat. You see the top curve The top curve is nitrogen. So the maximum requirement is of nitrogen, and then you can see it keeps on increasing almost up to the beginning of the end stage, that is of 200 is showing, right? And then if you take these three, calcium, magnesium and sulfur, these are required in very low quantity and then very gradually they increase till the end. And the potash, if you go to the potash, it is slightly below the nitrogen and it is required in that quantity. And that's why certain fraction of potash and certain fraction of phosphorus is applied through Basal, which is available immediately to the plant, and then since it is slow release, it is given before the planting or at the time of planting, so that they are available at later stage when they are required more. If we look to the crop of corn, you can notice the difference in the curves. There is a sudden increase of requirement here in this segment. This is the crop development stage, more than in case of wheat. And you can see these two curves which were so apart, and the potash was so low in the earlier case. Here they are almost merging, or they are almost going parallel, and the curve here is is just the very low level potash. The potash requirement is much less in corn, but phosphorus requirement is almost equal to the requirement of the nitrogen. If we look to the crop of garlic, the nitrogen requirement is almost similar to the pattern of wheat. And then there is another curve here. There is the requirement of the sulfur is quite high, and then least requirement is phosphorus. So this way you will see the with crop stage, with type of environment, climate, soil and all, more important with stage of growth of plant. For different crops, these curves are different, and here I cannot show all the curve. You'll have to refer to the lecture notes where I have given the specific nutrient requirement of more than 40 crops. You can kindly see there, and if you need any further information on this particular topic, then again I will request you to refer back to FAO publication number 58. Now we all understand what is fertigation. It's application of fertilizers along with irrigation water. To calculate and to schedule fertigation, we must understand several parameters, like what is the actual fertilizer that we have to apply, and at what time, in how many doses, and how much through basal application, how much through fertigation, how many number of fertigations will decide what is the fertilizer injection rate. Now this is an important parameter, that how much fertilizer you are applying in how much time, what is the rate of your application of a particular fertilizer. It is important because if you keep this rate very high, then the concentration of a particular chemical, particular nutrient in water could go very high, and there are limits prescribed for comfortable growth of the plant and plant acceptability. For example, plant does not accept more than 150 to 200 ppm parts per million concentration of nutrients in irrigation water. So when we decide, when we fix the rate of application of fertilizers, we must calculate back that what is the actual concentration of this particular nutrient in irrigation water that is reaching the plant roots. Now, how do we calculate that? For calculating that particular thing, we need to calculate all this. Recommended dose of fertilizer must be known, correction factor must be known, soil health must be known, basal application dose fraction we must know, duration of each irrigation. We know because fertigation has to be a small fraction of the duration of irrigation. It cannot be equal, it cannot exceed. Minimum duration of each fertigation. What is the minimum duration? Because this minimum duration will actually ensure that the concentration, final concentration of nutrient in the irrigation water is within limits. This is one way, and the alternate method is available of estimating what is the total quantity of fertilizer you must apply. It is on the crop yield basis. If we want to have a target, some target that we want to have potato from this field at minimum 40 tons per hectare, and we must know what is the requirement of NPK, the major nutrients or any other micronutrients per kg production of potato. So we calculate back, if you want to have 40 tons, how much is the nitrogen required, how much is the phosphorus required, how much is the potash required, and for meeting that requirement and going by the soil health and basal application norms and minimum duration of each fertigation, we can decide the durations of application and number of splits and number of applications of fertigations to a crop. Now, normally the fertigation is done using the liquid fertilizers. Liquid fertilizers, all these are available in different concentrations and different combinations available. Nowadays, people know 19, 19, 19, 20, 20, 20, 12, 61, 0. Means all sort of combinations are available. And if you go for these, then you must take care that this 19, 19, 19 fertilizer means it contains 19% nitrogen, 19% phosphorus, and 19% potash. So what needs to be taken care of is, you have seen the fertilizer requirement curves. They are not straight lines. They are not parallel. So you have to understand that if you are giving a 10, 10, 10 or 19, 19, 19, either you are applying more than what is required, a few nutrients, or you are applying less than what is required. So must take care of all these parameters. The other fertilizers available are granular fertilizers, which are normally used through foliar application or mechanical application on the surface. Now, not all the granular fertilizers can be used through fertigation because of the particularly the problem of solubility. What we need, which type of fertilizer we need, granular fertilizer we can use through fertigation, is the one which is 100% water soluble and which has the minimum filler compound in it, which can be dissolved and then filtered, whatever is the filler material that can be filtered out, and thereafter it remains a perfect solution. And list of 100% water soluble fertilizers are available. You can always refer to and then see whatever whatever is available, you can calculate how much is the quantity required. Now, along with the fully soluble, we have to also take care that it dissolves quickly and then it does not precipitate. And high nutrient content is preferred because when we make the solution, the amount of solution or quantity of solution is small, then there's an added advantage that we will need a smaller container to store the solution. And no chemical interaction between the application, the fertilizer that we are applying with the irrigation water. So that has to be taken special care. And minimum content of conditioning agents, that is the filler material, they should be at the lowest. I had referred to the compatibility at one point of time. The compatibility is that if you apply 2 or more fertilizers together, then they should be compatible with each other and they should not form any precipitation, or they should not get into any chemical reaction causing harm to the system or to the plants. This is the list, this is the table that you can refer to, what are compatible, what not. The C is the compatible. Now, for example, ammonium sulfate is compatible with ammonium nitrate. But if you take the case of calcium nitrate, is the least compatible with ammonium sulfate. So this way, referring to this table, you can find out whether the fertilizers you are using are compatible or not. Now, solubility is also a function of the temperature. And as the temperature grows, the solubility improves. But when the temperatures come down, then the process is the reverse. So one must take care that of the temperature. Here we are seeing a small figure indicating when to apply the fertilizers during irrigation. In the first, at the top line that you see, the blue is irrigation. The first 1/3 period of total irrigation, it is pure water with irrigation with pure water. Middle 1/3 duration is fertigation, and last 1/3 is again with pure irrigation water. In second case, the fertigation is done in first 1/3 segment and remaining 2/3 is the irrigation. In third case, the irrigation is done in first 2/3 portions and last 1/3 the fertigation is applied. And the last option is that fertigation is done all through the entire irrigation period. Which one is the best among all this? Any ideas? The option 1 is the best, as the distribution of the fertilizers will be appropriate and there is no possibility of any chemical remaining within the drip system, so possibility of choking is the least. If you take the case number 2, fertigation is applied early, and where these fertilizers are likely to go? They will go to the outer periphery of the wetted area. And if you take the third case, yes, the fertilizers will remain within the wetted area and very close to the plants, but some of it may likely to remain within the irrigation system, which is likely to choke or clog the system. And particularly the option of continuous and for the entire duration fertigation is not recommended, because of obvious reasons of problems of clogging. Now this is just the limit that I was explaining, that what is the maximum concentration of different nutrients that the plants will like to have at their roots. For example, nitrogen, it is average limits are 150 to 1000, but it would be comfortable at 250. Similarly, all other limits are given here. With that, I think I will pause. Now I'm going to present a decision support system, DSS, namely IFSHED IFSHED for scheduling irrigations and fertigations. This decision support system has been developed at Water Technology Center by my team in 5 years' time as a special project of the Ministry of Agriculture. I'll be discussing all that in due course with presentation. This is a web-based support system. It is available on internet and it can be used on different platforms available in web, on OS, Windows and Mac. And it is a responsive website. You can have all interactive information available, and then it is the one thing very positive, that it can be accessed through any device, maybe laptop, maybe computer, palm top, pen top, maybe a mobile. So it is a very versatile sort of software. And on front end it is the PHP and HTML, and web tools we have used is Ajax and CSS, ArcGIS and JavaScript. We have interfaced wherever needed, and in backend support we has for database, because it has got a huge database I'll discuss, and MySQL and Apache web server we have used, and Google Analytics fonts we have used in the program. You will see. Now this is the opening screen of the software. If you open this says DSS IFSHED is a home screen, and it talks about the whole additional support system, what it does, what its capacity, and then how can it be used, for what it can be used. Along with determining the irrigation and fertigation schedules, we have also taken an opportunity to provide the district level information of all different things, the data, government schemes, scheduling of micro irrigation, state micro irrigation directorate and contact addresses, and then fertilizer manufacturers and suppliers. All those informations can be accessed, as you can see here. All these subtitles that you can see, then general information also has been made available to the user. Similarly, the information on district level information, general information of all districts in the country. Now the task is that you can understand the magnitude of the task. We have 600, more than 600 districts, and the software has got all general informations about each district in the country, so one can really get the basic data from this. Now it comes to the schemes, government schemes, and NMSA, MIDH, NHM, PMKSY, NMOP, GDB, all these schemes of Government of India. There are the links provided with this. You can very quickly access any of these schemes from this DSS. Next come the scheduling. Now it works the scheduling starts from here, and it asks irrigation scheduling or irrigation and fertigation scheduling, what you want to do. If you want to use it for both, then it will go as you decide. Once you say yes to this, then the first screen, it asks the user to identify himself or herself. His identification is not that very important. It is only we are asking to send him the report, what actually final report comes through in a digital format. But we are more keen to identify his location, because the one thing that the decision support system does, gives the data to the user. Because you have seen through discussion, earlier discussion, that how much data will be required in determining the irrigation and fertigation schedules. So all that data may not be available with the user. So if user doesn't have that data readily available, this DSS provides him that data. And how will the DSS provide? It provides the basis on the district that you identify. So the location of the district is very important, particularly from the point of view of the data that a person may need during the course of the determining the schedules. Now, for example, first is the soil information. The moment you identify the district, the same district map comes here by the interface with the GIS, and the information that is asked is your field size. So what is the field information? What is the length? What is the width? What is the and then type of soil and all the parameters, they automatically are taken care by the software itself. Next comes the information on the crop and its growth stage phase. You identify the crop, immediately you see the figure of the crop coming here, and that is to ensure that you have selected the right crop. This is what you were looking for. And once you identify that crop, and if this crop is correct which you are identifying, different stages, length of different stages is already given here, and you need to only identify when you are sowing. The rest of it, initial stage will last when will the development stage last, and all this information is embedded in the program. It will automatically be available to the user, and the user need not bother about that. Next comes MI system information. What is the system installed in your place? What is its capacity? What is the application rate, the water application rate of the system? So without knowing that, we cannot decide the irrigation duration. And once we know the irrigation duration, then only we can fix the duration of fertigation. So system information, whatever is there, that you will have to provide, what sort of system you have, and what are the basic components of the system. Then will come the nutrients. Now comes the nutrients. What is the nutrient requirement of the crop, and what is the recommended dose? Once you have already given the crop, the support from the DSS will come. It will give certain values. If you want to keep them, fine. Otherwise, you can alter them. And anytime, any data that is provided by the DSS, if you want to alter that, if you have a better data and more accurate data, please enter yourself, and that will superimpose on the value provided by the DSS, and it will calculate as per your data. Next comes the out of the total fertilizers that is required, what is the dose what fraction of that is to be given as a basal dose, that is calculated here. Next comes what intervals you want to have, and then would you like to apply complex fertilizer? Complex fertilizer is the one which has got more than one nutrient in it. The complication would be that, let's assume a fertilizer has got all the three N, P and K in certain ratio, but the plant of course needs all N, P, K, but the fraction, the proportion the plant requires may not be matching with the proportions of the fertilizer. So this fertilizer needs to be supplemented by other fertilizers to match the actual requirement of the plant. So this DSS takes care of that and does the exercise for you. And now it asks, what are the fertilizers available to you? Nitrogenous fertilizer, potassic fertilizer, phosphoric fertilizer. What are these fertilizers available to you? A list is given here, which are water soluble fertilizers. A user has to just identify which particular thing he has with him. And then it will come as simple with a question, what frequency you want to have for irrigation and what frequency you want to have for fertigation. Inbuilt in the system is irrigation, you can go 1 day, alternate day, 3 days, 4 days, 5 days. But for fertigation, we have 1 day, 2 days, and weekly. So you just pick whatever frequency you want to have, and then otherwise it will automatically suggest, depending upon the data that you have entered, soil, your system, your crop, it will automatically give certain values. If you agree with that, fine, go ahead. Otherwise you can change and put the schedule, decide the frequency yourself. After you have done all that, it would give a report, and the report would contain like this, information like this, a bigger table, huge table. Starting from the sowing date, every day, what needs to be done? If you have given irrigation daily, then it would give irrigation how much amount of water you have to apply every day. And if you have given the fertigation weekly, then every week it will give the values of N, P and K. Not N, P and K, but the fertilizer that you have selected, how much fertilizers you have to give on this particular day of N, P and K. All this will come in this report. And finally, it will give you a presentation that your plant or the crop that you have to be growing requires irrigation in this format and requires N, P and K in this curve. So this is the curve that this schedule developed will meet these requirements, and your plant productivity is likely to be optimum or very high. Along with this, the DSS also gives some general information about the mission directorates, because government is giving a lot of support for drip irrigation system, fertigation system, and the subsidy for fertilizers. So what we have given here for different states, all the mission directors' addresses have been given. If you need to contact them, you can directly take the help from the DSS. And then it also gives a list of manufacturers and suppliers of the main suppliers of the fertilizers. You can select from your area, and that's what we want to discuss in this class. So we have discussed different aspects of water distribution, fertilizer distribution, and crop specific requirements of water and fertilizers. And then we discussed a decision support system, if shared, that can prepare the irrigation and fertigation schedules to match the specific requirements of the crop grown for maximizing your productivity and profits. Thank you with that. Your queries keep with you, and they will be taken care of in some of the interactions or webinar that we'll have later. Thank you.